Uh, Hello to my supervisor and coordinator. So I can introduce myself first. So my name is Hong Lee, and right now I'm currently uh, in the Master of IT. My major is software development in UTS. So this course is about research project, and what I'm gonna do for this project is to present a VQ system, visual question answering prototype based on the multimodal study. So VQA is a challenging AI task where the model is asked to look at an image and answer a question about it. So it combines both visual understanding and natural language processing, requiring a fusion of image and text features. And my goal was to build a working prototype that completes the four VQA pipeline from image input and visual features, extraction, token level fusion, and text generation. Although the model answers are not yet perfect, it demonstrates the feasibility of architecture and sets the foundation for future improvements. So in the rest of the video, I will walk through the system architecture, dataset processing, model training, and a few live demo results. So thanks for watching. Okay, so for the next section, I will give a detailed walkthrough of the system architecture I implemented for my visual question answering system project. And for the entire pipeline, it's made up of 7 core modules, so forming a complete flow from image input to text output. Okay, so let's move to my code. All right, so for my project, so firstly, my first step is I use visual model. So name is Visual VIT base 32. It's a encoder only visual model. I choose this model because the output of this model is patch token is fit for the llama model. So for this logic is implemented in the encoder VIT. So it's in this Python file. So in this file, so the input image is split into some patch and get the correct output tensor. So that meaning each patch token has 512 dimensions. So these features are then projected to match the next embedding space. Okay, so next we're gonna start with the text processing. So I used uh, Llama 3.2 model. This is a decoder only language model. Okay, so firstly, I gonna let the user input text and go through the tokenizer to token ID and to and next step is embedding. So get the token embeddings. So in this way, I gonna make it come true in the Llama wrapper. Uh, because in this part I gonna make it's like a regular test process in Llama model, so I just use the most functions in the original Llama model. Okay, so all right. Since the image token is converted from 512 dimension and the llama expect 2048 dimension token, so I build a MLP projector which is include 5 layers. So this is in my MLP projector. So you can see, so the first layer is from 512 to 768, and the next is to 1024, and next is 1536, and so on. It gonna operate gradually. Uh, each layer gonna include relu activation, layer norm, and dropout. I train this MLP so to ensure that the image feature align with language token space. So that's in this way. Okay, so for the next step is pretty major and it's pretty important in my whole project. So right here, I gonna add a image. I gonna add an image label to the promote. So it's it is like I use the lava style fusion strategy. So you can see like the image is placeholder is insert in the promote. So later in the lava fusion and fusion forward. So in these two file, uh, you can see so I replace the token with projected image token, and so in this way they allow the model to attend to the both image and text in the coherent sequence while preserving llama's autoaggressive behavior to like text to do the text generation. Okay, so another one is also important. It's about my attention mask. So I create a custom attention mask. So in my project, in my settings, so the image token can attend to text, but text cannot see image token. Image token can see each other. So this design ensures the visual signs are currently handled during the attention computation. And also for the padding mask, so it is like set for the value 1, so the attention can see the right token. The 0 is has been blocked. Okay, so for the next step, uh, so I finish the most of the steps. So right here we're gonna forward the llama model. So the first sequence and the mask are passed to the llama transformers layer. So I use the fusion forward to make it push forward to run the llama model, and in this way to generate the immediate hidden state. So it's right here. Okay, so when we finish the forward, we get the output from the hidden states. So right now we're gonna generate a new answer from the hidden state, but I cannot use the original function from the llama because I insert the image label like a placeholder. So I gonna use a new one. So I added the new position ID. so it's make sure the it's gonna make sure like the lava model gonna recognize the image placeholder. Okay, so that's general steps for this model. So all the model modules is integrated in the main fusions Python file. So I'm gonna use like a purse to implement the trigger with a single function call. So you can see, although the current model answer I think still need improvement, but the implement pipeline confirms that the future architecture is valid and provides a strong base for the future optimization. Okay, so from this part, I'm gonna introduce about my uh, dataset and something about training details. So, okay, so uh, firstly, for the dataset, you can see I use validation set of the VQA V2 dataset. So, which is widely used benchmark released by Microsoft for visual question answering. The data comes into two JSON file, uh, and one contains the image metadata, and the other contains the question and answers related to each images. So each train simple consists of the image ID, a question, and reference answer. So I parsed the JSON file and constructed paired input of the feature and question test for my training. So the image are processed into the tensors, and the question are tokenized into the embeddings to supervise the projector. Okay, so back to the MLP projector training. So this is a script. So this is a script about my training. So its goal is map 512 dimension image tokens to the 2048 dimension space of the language model. So as you can see, I use MSE loss to minimize the difference between the projected image features and simple text token embeddings. Well, the alignment isn't perfect. It provides a weak supervision signal for training. The train runs for about, as you can see, is about the epoch is about it's about 30, and with a learning rate is about 5A, epoch 30, and 5 minus 5. So I use gradient accumulation every 4 steps to stabilize training and apply dropout and layer norm in the MLP to improve the generalization. Okay, so from the trailing, so there's little problems. I think so just cause incorrect text generation. So firstly, it's about the I think it's about the formulate of the data set. So I just use mm, VQA V2. I think this formula is not correct for the like a lava style multimodals inference or training because I just set the image placeholder for that. So maybe I need to do some modification hmm, to make the training better. And another one is for the early stop. So I think I just later I just set for 10. I think it's a little bit more and maybe just a cause the training get overfeed. So maybe it's not good point to get the image feature. So and also for another one for my MLP projector and I think I got the forward so I got 5 layers from 512 to the final goal is to 2048. I think 2 or 3 layers that should be enough. This part maybe is too many. So but the time is not enough. I gonna try that after this project. I'm gonna continue to do the research. Okay, so now I'm gonna demonstrate how the system perform on the real examples. So firstly, um, I'm gonna show you from my text generate log. So I do have do the logging about my generate. So let me see that. So as you can see, so the time is in May 7th. So I this is the steps of my uh, lava model, and this is the text generation. So I know this one is not this is not correct, but this sentence from the lava model I think it's not pretty well, but the pipeline is the pipeline is it can be walked through. Okay, so right now I'm gonna try the model on collab. So because the collab just update, so I just uh, do a little bit modification, but make sure it can run. Okay, so I just change the directory and use command Python to like I use the image. So this is a directory of image and the text is describe this image. So generate maybe just takes me about like yeah several seconds to do that. Um, okay, so the first one the text generation is already finished, but the pipeline is good. I just mentioned maybe it's of the MLP, maybe of the dataset, but I gonna check it later. The time is not enough, but anyway, I finished the pipeline for this project. So during this project, I because my major is about software development, so I learn everything from the beginning. uh, and I learned a lot about AI, about transformer architecture, about multimodals, about vision models, pipeline, and input IDs, and many knowledge, and I am really interested in. So in this project, I'm pretty happy uh, to learn about that. If I have a chance or opportunity to do something about AI research, I'm gonna continue to keep my mind in this research. So thanks for watching.